My name is Yuna. You can find me on the internet at UNA. Like you heard, I'm a UI engineer at DigitalOcean. DigitalOcean is the cloud for developers. We provide server infrastructure and virtual machines, along with a lot of other new services. I'm really involved in the CSS and Sass communities, design systems communities, and I do a lot of work with accessibility and performance. I'm also writing a book that I just announced. It'll be coming out in fall of 2017 about all of the things front end, everything from how to learn, how to make communities, to HTML, CSS, JavaScript, internationalization, SEO, all those things. So today we're going to talk about one of the things that I mentioned, and that is how to optimize images on the web. Now, we're going to go through a couple steps. The first thing, we're going to talk about the problem. How did we get here today, the image cruft that exists on the web? Then we're going to talk about what's coming next. These are going to be new image formats that people are currently developing, what we're doing with existing image formats as well. I'm going to talk about solutions, from automatic solutions you could set up once and forget, to manual solutions for those bigger images that take up a bulk of your site. And then we're going to go through an example. And in this example, I'll show you how to get rid of 68% of the image data on first load without losing any visual information. This becomes a lot of size that you're saving your users. And before I continue, I want to stress that image optimization is not just a development problem. This is a team problem. It doesn't matter what your role is. The experience that you provide your users is your product. So we can't have this. That's a laptop, by the way. We can't just throw over performance to another team. This has to be something that we all take responsibility for. So first of all, how did we get here? It all has to do with the technology that we currently have today. Here is a chart of camera ownership. As you can see, camera ownership has increased over time. That yellow bar is smartphones. It's gotten cheaper to take photos, to keep data, and to share large files. And we've kind of forgotten about this, because the best camera is the one that you have with you. And who here has a camera with them? Who here has a cell phone? I'll ask another question. Who here doesn't have a cell phone? Exactly, everyone does. So I want you to do a favor for me and take that cell phone out of your pocket, hold it up in front of you. Yep. And take a selfie. I want you all to take a selfie. Selfies are a great moment of confidence. If you don't like selfies, take a picture of like something else, this beautiful theater, the person next to you, surprise them. But everyone in here, just take one photo. Okay, now keep it. So these cameras that we have with us today take 12 megapixel photos. That's the size of the images that occur on the camera that I have, my iPhone 7. And on the average iPhone 6, a single photo is 2.6 megabytes. And 2.6 megabytes is over double the recommended total size of initial page load of a single website. So we here have just introduced 1,500 megabytes into this world. We've introduced 1.5 gigabytes of photos. And that's only if everybody took one photo. Who took more than one? Yeah, I know, most of you did. Don't lie to me. So this is what we're doing. We're at a stage of irresponsible imaging. We're taking and sending photos, putting them on the web without really thinking about the consequences of this. This can really easily turn into petabytes of data. And this is what we're doing to people with irresponsible imaging. We're doing this to them. And so you might be thinking, so what? Devices are getting better. Network speeds are improving. And the classic, like, oh, it works on my system, especially in local development. Well, here's a fun fact. Last October, for the first time ever, mobile and tablet usage eclipsed desktop usage worldwide. So now, the new standard, the new baseline is mobile usage for any website and any application. Google did a study from September of last year, and they surveyed over 10,000 mobile websites on 3G connections, which again is the standard now. So I want to play a game with you to go over some of this information they found, because I think it's really fascinating. So to prep for this game, I want you all to just start yelling out numbers at me. Any number. 12? 16. Okay, 16 I heard. 42, that's always the right answer. So now we're going to play the game. All right, so average load time they found for mobile sites is how many seconds over 3G? Just guess. 14? 6? 20? That was really close. The answer is 19 seconds. So it took 19 seconds for the average mobile site to load over a 3G connection, which is not even a bad connection. So mobile sites that loaded within 5 seconds versus the average of 19 seconds were found to have how much longer average sessions? How much longer was a user on the site? 7, you said? 54? 70, so multiply that by 10. 70%, oh, you said 70. Oh, maybe he knew. So what percent of visits to mobile sites are abandoned after 3 seconds? We haven't gotten to 5, we haven't gotten to 19. We were just at 3 seconds and we're done. 38, 40? The answer is 53. So over half of visits after 3 seconds are just done with the wait. They don't have time for this. This is how they feel. So in the US, there's almost 290 million people that use the web, that are web users. And that's 88.5% of Americans. Now, Croatia is a much smaller country. There's only 3 million people that use the web, but that's still 75% of people in Croatia are connected to the web. Now, compare those two to a country like India. India has almost double the internet users of the US, and only 34.8% of the country is currently considered a web user. So that means that there's huge market potential here. And this is only projected to grow even further. This is going to grow exponentially. This is what people refer to when they talk about the next billion web users. It's really going to take over what we're currently seeing in our numbers today, and it's already beginning. And it's even more stark when you compare that to web speeds. So in the US, I'll compare it to, again, the average connection speed is 12.8 megabits per second, and the average peak connection speed is 57.3. So that's like the best Wi-Fi you're going to get. Now in India, which has almost double the users that the US does, their average connection speed is only 2.5 megabits per second, and the average absolute best internet they can get is 18.7 megabits per second. So this is so difficult, it's so frustrating that the majority of these people that are using the internet have to put up with this. Access to information should be a basic human right. By not paying attention to performance, we're restricting access to information for people who don't have the fast connections that we're used to. And that's why I like to say that performance is not a progressive enhancement, it's a core part of your product, because people just won't use it. Back to Bob Ross. You can have anything you want in the world once you help everyone around you get what they want. So I have a friend who, her name is Sari, she's a London-based developer, who recently went on holiday to Iran. And due to less speedy connections that she's used to, along with a timeout, because you had to enter a verification login, it had a timeout on it, she couldn't even log in to GitHub or to Slack. So how can you even get work done if you can't even log into systems that you have to use to work? This is a massive problem. And she also found that images were a big problem as well. She was saying that she realized how many sites still load high-quality images, even for small devices and small bandwidths. This is very frustrating, especially when you consider this. If you look at all of the data that is sent to you on a website, this is from the HTTP archive, they do this run pretty frequently, you can see that images clearly take up the majority of what we're sending people on the web. They're the biggest asset by far. 66% of what you're sending is images on the web. And that's gone up 2% since 5 months ago when I first started doing this research. It went up 60 kilobytes since then. The average single JPEG file, just one, is 2.3 times bigger than the average JavaScript file. So while people are arguing about including jQuery or not, like you can get rid of an image and then have all the scripts you want. I'm not saying to do that, but if you consider this, this is why image performance is so crucial and people usually don't think about it. Developers think of it as a design problem. Designers think of it as a development problem, and people aren't solving this problem. This is a great quote from Tobin Titus from ImageCon. He says, "You can't be a web performance expert without being an image expert." And I feel like that's so true, especially when you look at the field of images out there. So this next section is about understanding those tools. There's so many image formats. Don't try to read the slide. This is just 23 out of over 70 that I discovered while researching for this. And the problem is that every platform uses a different image format inherently. So just look at emoji alone. On Android, they use BMP to represent emojis. On Mac, they use a format called SBIX, which is an extended BMP. On Windows, they use something called color, COLR, and that's a layered vector. So people can't even agree what to send emojis as. Now let's take a look at some of my own artwork. My original tree by Yuna. So this just goes to demonstrate that different images are better suited to different format types. Like you can see here, the PNG and the SVG are better when you have these large blocks of color. And when you have a rasterized image with a lot of color variation, gradation, and change, the JPEG wins. And that's because of how images compress. So it's important to understand why and how those images compress to understand which formats you should be choosing and using for your images. So I'm going to talk about a couple formats. I'm going to talk about the GIF, the PNG, the JPEG, the WebP, and the FLIF. And the FLIF is like a very new experimental format. WebP has been out for a while. It's still relatively experimental because of support, but they do create really great improvements for images that we can see in the future. So if we start with the GIF, a GIF comes in 256 colors, in addition to the raw image data that's stored and displayed at any time. It doesn't support transparency, but it allows for dithering. You have this dithering control. And what dithering is, it's the addition of noise to reduce distortion. It looks like this. You can see that there's dithering on the right here that allows for a smoother visual change of the colors. There's two types of dithering, and they do affect the size of your file. There's noise dithering, and this noise dithered object is at 77 kilobytes. This pattern dither is a different type of dither that's more even throughout, and it's also 10 kilobytes smaller. So I kind of really like the noise dither because it's more performant, and also it kind of reminds me of cross-stitching, which I think is pretty cool. But that's another micro-optimization you can make. Save things as noise dither, save things as pattern dither rather than the noise dither. So after the GIF came the PNG, and the PNG was this open source reaction to the GIF threatening to license. Now the PNG comes in this 8-bit variant, but it also comes in a 16-bit, 24-bit variant, which is this true color. You have 16 million colors to choose from. And because of the better compression, it's usually better to choose the 8-bit PNG versus the GIF. It also allows for alpha transparency, and it uses delta encoding, which means that a PNG is lossless. It doesn't ever lose data. So let's talk about that for a second. What is lossless versus lossy compression? So the PNG uses delta compression, and what that does is you have like a long string of letters, like A, B, 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 C. What it'll do is it'll save it as like 4A, 3B, C. So if you have these large blocks of similar colors, like the sky, it's going to be looking for the differences between those. And if the difference is the same value, then it'll really compress it and save it to be a smaller file. It also doesn't lose that data because it's just compressing it in a different way. What JPEG does is it looks at the entire image, it looks at all those numbers, and it just gets rid of some of the data that you don't need. It makes these optimizations based on years of work and algorithms and how the human eye sees. So you're always going to be losing data when you save a JPEG. Even if you save an 80% JPEG at 100% the second time, you're still going to lose data. That's just how JPEG works. And you can kind of see it, like JPEG is going to always rewrite every single item within the file type, whereas PNG has these similar blocks that just say comma, move on to the next item. So the way that JPEG compresses itself is really smart. It goes through this several-step process for compression. It starts with the RGB layers, and then it breaks those up into the luminance, which is the Y, the red chroma, and the blue chroma. Red chroma is red-green, blue chroma is yellow-blue. It goes through this discrete cosine transform, and then it goes through a quantization table. The quantization table is what you set when you set the quality level of your JPEG. So you have control over this. It's a set value. And then does a zigzag scan through those 8x8 pixel blocks, and it applies these transformations, goes through another algorithm. Huffman algorithm is a pretty common one, and then it saves it out to be a new converted value. So it saves a lot of space in the server, and lossy images aren't necessarily a bad thing. Now, people are still building on the basic JPEG. This recently came out, this idea of Getsley compression from Google about 2 months ago. This is super new technology they used, and instead of this like Huffman encoding step down here, what they're doing is they're using this Getsley compression instead. Now, what this claims to do is to compress JPEGs at 35% smaller than currently available methods without changing much there. You could see sort of in the middle is the Getsley here. On the right is the normal PNG compression. It makes a little bit of a difference. It's a bit vivid in the color. It's more vivid here. But it uses this AI-based compression algorithm, which reapplies every single one of those 8x8 pixel blocks. So instead of using a single quantization table, it's using many, many quantization tables as it goes and compresses. And this is kind of like helping make it a more natural compression. It makes it a smaller compression, but it also has its negatives. It takes much longer to compress images. So there is a big trade-off here. It's going to take a lot longer. It's also not really great with smaller images because, as you can imagine, each of those 8x8 pixel blocks, you're not going to really get more out of it if it's small. If it's a larger image, it works better. But at the same time, the larger image is going to take a much longer time to compress. So recently, somebody came out with an article, Eric Portis, who works at Cloudinary, which is an image performance service. He compared it, the Getsley, to the regular automatic quality compression that Cloudinary provides for their users. And he saw that it really wasn't that big of a change. You do lose some of the data in the background, so the compression is smaller, but it's not that much smaller. It's exciting to see these kinds of things becoming something that people are researching because it means that images are going to become smaller in the future, which we need. We need in this world. And if you have smaller images, smaller sizes, you can't really notice the difference. Like these mounds up here, especially on this screen, you can't see much of a difference between them at this small size far away. But the change happens in the histograms. So you can see in the histogram of the 10%, those peaks, the color peaks are going to remain, but all the colors in between them kind of get cut off. And that's really what happens when you see this distortion, this banding. Here's a sort of close-up of that. If you have a gradient, you're going to lose the smooth gradient because you lose those in-between values, and you're going to have chunks of color in the gradient. So usually 80% quality is a good medium. Honestly, most of the time 60% quality is good. And if you have small images like icons, save them at like 30%. You're not going to see a difference at all, and it will save you a lot in image size. So I heard these names popping up a lot also as I was researching JPEGs, and again, the problem is nobody can really decide on the best implementation. So according to jpeg.org, there's JPEG, JPEG XT, JPEG LS, JPEG 2000, JPEG XR, JBIG, JPEG XS. Like, why are there so many different types of JPEGs? You know, while people are arguing about all the different JavaScript frameworks, look at how many JPEGs we have. And the only really big difference between this comes down to support. Who was working on this research project? So, like, here's support for JPEG 2000. This is Safari mostly. JPEG XR is, Microsoft is running that. It works in IE and Edge. So now we're saying, like, IE and Edge use JPEG XR for optimization. Safari use JPEG 2000. And Chrome is just like, just use WebP. Welcome to the web in 2017. So WebP is, I think, the most promising new image format that we have today. It was initially developed by On2. It was a company that Google then bought, and in 2010, they've been putting a lot of work into it. WebP allows you to have lossy or lossless compression. It also supports transparency, which makes it comparable to both JPEG and PNG. So you can use this to pretty much replace all of your raster-esque images. Anything that's not SVG, that's not a geometric drawing on your page. So this is an example that I did my own compression on, and you can see that there's a legitimate savings here. There's an average of 30% savings in lossless compression, which is not bad because, again, you get to save all of the pixel data of your image while making your image smaller, and that's pretty cool. The way that WebP works is through predictive coding. Predictive coding uses the values in neighboring blocks of pixels to predict the next value, and it only encodes the difference. This is something that's inspired by videos. Like, as you move in videos, when you have a video that has a lot of movement, it's a bigger video than a video of somebody that's sitting in one place and talking to you. So this is kind of inspired by that. And it also has sort of a different histogram here. Even if you compare like the 60% JPEG savings here to the WebP, it looks slightly different. So talking about support isn't super strong yet, but Safari and Firefox are both experimenting with it, so that's a really big sign, considering what we just talked about, that nobody agrees in anything images in the world. And you can also use a variety of polyfills, etc. If you want to convert to WebP, there's so many options. I personally like the ImageMagick CLI because it's super fast. If you're on Mac, you can just install Homebrew and then brew install ImageMagick, brew install WebP, and get it going. On Windows, you can install a binary from imagemagick.org, and you can get all the sort of items you need through that. And then in just one line of code, if you're in the folder where all your images are, you can just say mogrify-format WebP from JPEG. So you can also use a WebP polyfill. This is called WebP.js, and it works in IE 6 and above. And in a study done by Adrian James and Matt Scholl in a post for Smashing Magazine, they determined that this was sort of the easiest, most lightweight solution for all browsers. However, I think it's kind of weird to require JavaScript for your images in Firefox or Safari or Edge. That's not cool. So instead, you might want to do this conversion server-side or use something called the picture element. Now, the picture element is like some piece of HTML magic that we can use instead. Here, with the picture element, just like with video, we can send multiple sources. We can send our source, and then we can have our backup image that makes this a progressive enhancement. We can send a JPEG if the WebP isn't supported. And this, I think we should all be using because the users that will get the WebP will have a better experience. The users that don't will just get the JPEG. So the picture element also has pretty good support here. It's supported in Edge, Firefox, Chrome, Safari, all the major browsers. But if you do need to support IE 8, IE 10, IE 9, 11, you can use the picture fill polyfill, and it only comes to 8 kilobytes, and it does support Internet Explorer. So just like WebP, WebM is now a Google initiative. Same thing, WebP was inspired by WebM. They acquired the same company. It has less support than WebP does, but I'll get to in a second why this is okay. So you can convert to it. You can use a visual converter if you don't like the command line, and it makes a massive, massive difference, especially with video. This is almost half of what the MP4 size is with the WebM, and it looks the same. The quality looks almost identical. So the reason why you don't need a polyfill is because with video, you can just send multiple sources, and all browsers support this. This is something that HTML is always allowed. So you can always be sending your WebM videos along with your MP4s if you want, or whatever other image format you want to send. So more options, more power here. Next thing I'm going to talk about is the experimental formats, and this is going to be Fliff. Now, if you remember, this is pattern diffusion. Like, once you see it, you never unsee it. So these are some of the future formats that I think are going to be really exciting. Free lossless image format is what the Fliff is the shorthand for. And on its site, it claims to be all of these things. Smaller than the WebP, and smaller than brute force crushed PNGs. And they have this image corpus they're trying this out on, and in the sort of brown and red, the bottom here is the Fliff. You can see that's smaller on all quality levels. But the coolest thing about the Fliff is what it means for responsive images. A Fliff image can be loaded in different variations from the same source file. So the browser can start downloading at the beginning when it hits the web page, and then before it even finishes downloading, it knows how much detail is needed for the final render. You can put multiple images within a single file. This is kind of like a brain twist for us as we think of normal images. So you don't need that picture element. You can do it all encoded within the same image, the Fliff image. Unfortunately, the polyfill status is still in beta, but if you think this is an interesting topic and you want to take on, working on this, it's all open source, and I'm sure they're looking for contributors to kind of help push this. I think it's a really great initiative. So while that's so many things, it's 2017, we're developers, we understand that there's a wide world of options out there, and to pick the best one for you. So let's talk about things that we should definitely be doing right now, and this is sort of the solutions and pro tips section. The first sort of thing you can do is just automate all the things. Automate your emails, automate your image optimizations. My favorite tool for that is Image Magic. So you can use Webpack, you can use the Magic Loader, there's Gulp, Grunt, NPM scripts, there's a different Webpack loader if you want to use it. There's a lot of options here. So just a node example, this isn't really doing anything, but it shows you in a few lines of code, in 5 lines of code, you can say, read all my files and then do a transformation. So you could set that in your code in whatever dev environment you have set up, and then you don't even have to worry about image optimizing because you've already set it up once and you don't have to think about it again. Now there's also this semi-automation phase here, and there's 3 tools here to be exact that I'm going to talk about that are great. The first one is Image Alpha. Image Alpha allows you to bring an image, a JPEG, a PNG, a GIF into this program and really customize it, change the background color, and change the color levels that you're applying to it to decrease the file size of it. Now you can use that in concert with Image Optim. Image Optim is literally the most magical thing that I've ever seen in my life. You can just drag a folder into it of your images and just see the image sizes trickle down. If you can't minify it anymore, it'll just have an X on it. If you can, it'll minify it to the best of their ability. So I like to say Image Optim always and often, #IOAO. So I got really excited about this because yesterday somebody tweeted this at me. They said that all in a day's work, image often, always and often, they saved 41.5 megabytes out of 41.6 megabytes. They saved 99.8% just by running this through image optim. It took them 5 minutes, less than that even, and it's super, super powerful. Think about your users. The last tool is SVG OMG, and this is created by Jake Archibald. It allows you to put SVG files in and play with the different configuration options to get what you want out of it, save this out, and use it for your SVG files. So those are 3 really good semi-automatic tools. And now I want to talk about the manual things. This is when you want to build a website. So, build me a website. Option A or option B. I'm talking about the big yellow area here. This is where you could really come into the cruft of your page. And these are kind of fun facts about what makes images more performant. I really like this quote. It's about human communication studies, but it really, really, really relates to performance. It's not what you say, it's what people hear. This really relates to this concept of perceived performance. It really doesn't matter what you're sending them, it's how people perceive it on the web. How are they accessing your site? So let's continue this game. Does anybody see the difference between these 2 images? They're the same physical dimensions. One is obviously much smaller, but what is the difference here? It's not the shadows, but I will say the image here, the smaller one, is blurred out. Oh, you can't even see up there. The parts at the bottom here are blurred out. So the details are kind of fading into each other, making the JPEG compression much easier here. And that's what makes this image much smaller. So blurring out the less necessary parts of your images could almost halve the size of your JPEGs. That's a little fun fact. And companies leverage this for their placeholders. Medium renders images and includes them as placeholders to show and overview the image until it loads and animates in. And we can do that too. So if we start with this image, it's 409 kilobytes. Let's save the image at 30 pixels. So now it's less than 1 kilobyte. It's half of a kilobyte. We could scale it up to fit its container and apply a CSS filter like blur. And then when it loads in, we can just animate in the color. And it creates a nicer user experience, a nicer perceived performance, and also creates a nicer visual for the user. They know something is coming. It takes up the geometric space they expect it to. And it doesn't take up that much data to send to them. Facebook also uses this, and because of how their GraphQL databases work, if they send a file that's less than 200 bytes, they can avoid an extra image request. So they use this technique to send images that are not actually images to their users, and then load it on the screen really quickly, and then once the page is loaded, the necessary content, they load in the full quality image for their header. And they're also doing a lot of other optimizations as well. So this is kind of similar to the idea that progressive JPEGs do. If you've heard of progressive JPEGs, they don't load from top to bottom like baseline JPEGs. They load in layers. So they're slightly bigger in size, but it does improve the perceived performance. I recently was at a conference where I was browsing the web, pretty slow Wi-Fi there, and I saw that there was progressive JPEGs in use here, and that was nice because I knew there was an image that was coming there. So you can save these out. You can run a Photoshop task to change these, and it's just an option when you save your JPEGs. So pro tip is to embrace the blur. The next thing I'm going to talk about is color. As you can see, taking color out of an image greatly reduces the file size of that image. But black and white doesn't have to be boring. And here I bring you blend modes. Blend modes are a really exciting part of CSS that allows us to really create art on the web. This is just a layer that's on top of this image. So blend modes, I know, do take a little bit of additional time to paint on the page. So I wanted to benchmark that. Let's benchmark that. Let's see what the impact is of the additional paint in comparison to the image savings that we're getting from making this black and white and sending it. So I went to Web Page Test, and I sent a colored image, a black and white image, and a black and white image with a blend mode. Just wanted to see what the comparison was. I found that the black and white image, the blend mode, was considerably faster than sending a colored image. But I thought, okay, that's not a fully fair comparison. Let's compare it to an image that looks similar. So like this pink overlay on a black and white image, right? So now we're saving 115 kilobytes, not 190 kilobytes, in the difference here. So again, I ran the study. I sent a black and white image, and then I sent a blend mode with it, and I compared that to an image that was pre-designed in Photoshop with the pink overlay on it. And again, I found that the bottom row wins here. That's the image with the blend mode. So it's still faster to send a black and white image with a blend mode than it is to send an equivalent colored image in Photoshop. So blend modes are exciting. A note about accessibility, because this is support in Edge, if you do use the technique, remember to check your browser support, and also if you are supporting Edge and IE, then you want to make sure the image is above the color that you're blending it with so that the user will still see the image. You can blend the image, the photo, onto a color behind it, and that way it's a progressive enhancement. So I say, use these things. Here's just an example of an open source project that I built called CSSgram, and it also shows the power of these blend modes and filters. You can recreate any sort of visual you have in your head, any kind of filter, any blend mode, any layer on top of an image if you know how to leverage these tools. And here's just a recreation of the Instagram filters. The filters in CSS will animate, the blend modes won't, so you do see kind of like a mixed effect here. But if you want to play with these, it's una.im/CSSgram. At the end of the presentation, I'll share a bunch of links. So the pro tip here is less colors, less problems. I think this is a really good sort of summation of this. Like, you never really have to send a loading indicator if you know these tips and tricks about how to improve your image performance. Now let's talk about animated images. These are massive. So recently, I had to do a redesign of DigitalOcean.com, where the goal here was really performance and accessibility, and to me, they're one and the same in a lot of ways. So even after automatic optimizers, this thing here, this is massive GIF, it was still 600 kilobytes, and we wanted to get the home page of the site to load in less than 1 megabyte to make it performant for the users, to make something that they can see immediately and activate. So I ended up getting this 200 kilobytes smaller, over 30% smaller, by doing a few fun tricks. I actually brought this into Photoshop, and there's a timeline down here that you can edit. You can delete frames that look the same, and then increase the length between the frames surrounding them to recreate this. It kind of reminded me of Jask Paint Shop Pro, which I used to use back in the day. You can also resave this to use fewer colors in the color profile, and that's what really helped me get this GIF to a much smaller size. So you can format these frames. Now, there are a few GIF alternatives that are coming out these days. The APNG, the FLIF can be GIF-like, the BPG, the MNG. But now, we have something that we can use called GIF video. GIF-V is really the only GIF alternative format that has really taken off and shows a lot of promise. And that's because it's not really a GIF. What GIF-V is, it's a very clever thing that Imager did that preserves the GIF-V extension, but actually sends you a video in whatever format your browser supports, so WebM or MP4, and it really, really decreases the file size of those GIFs when they're sending them to you. I was recently talking to Jason, who works at Vox Media, who applied GIF-V to their blog, their SB Nation blog, which is their sports blog, and he said it saved them petabytes of data. It's just so much, I can't even imagine how much. So this is exciting, especially when you consider that silent video autoplay is back in iOS 10+. That's exciting. So now if you want to have these GIF-like images in your browser, you can have more performant videos that autoplay for your users if there's no sound to them. Why is video so much better than a GIF? It's all about how they work. A GIF stores every frame. It's like a lookup table. So there's no preloading, it just shows an image. Whereas a video, like I said earlier, stores the differences between the frames. So you do have it, it's more like a formula. You have to do that preloading. So that's why we should always use videos instead of GIFs if we can. We don't have to save this entire table. We can just store the differences. So let's go through an example now and just show these things in action, how much of an impact they can make. This is a conference that I spoke at called Mixin a little while ago in Australia, and they were kind enough for me to tear apart their website, let me do that. Really beautifully designed, but I think that image performance wasn't so much considered. It was a little bit. So the first step is to really determine the greatest common denominator size of the images. And this is sort of like, remember middle school math, the greatest common denominator? This is sort of like the quick and dirty, cheap tricks way to edit these images. So let's start. I started to take a look at these images, and I saw that this image is only 540 pixels wide, but it's actually sending it at 1560 pixels wide. So that was a big difference that we didn't want to see. And I kept looking at the site. There must be some place. And I found this. So the pictures were a little bigger. They were sent at 661, but we're still sending a 1560 pixel image. And then I found it. Okay, the widest size these speaker images ever appear is 780 pixels on the blog. We're still sending it at twice that size. So what we could do really quickly is, with our command line or something, just divide them by half, because we're never seeing a picture at any time bigger than that. Just divide this by half. We save a lot in our image size. Here's how you do it with image magic. And it really is just the lazy way to sort of improve images overall. So the reason why they had it at that size, though, is because we hear this advice, like save Retina images at 2x size. And I kind of want to challenge that. Because if you take a look at these two images, you really don't see much of a difference. And if you don't see much of a difference on your Retina display, then your users definitely won't see it. The difference comes in the image size. So this is, divided by half. It's almost 80 kilobytes versus 120. And then if we actually save it to the largest image size that image appears on the site, it's 60 kilobytes. So we're starting to see a 195% improvement in image sizes just by having the sizes of the images alone. And there's other optimizations that we can make throughout the site. So I ended up getting just the speaker images to 0.6 megabytes smaller by using this technique, by saving them at the actual size they're being sent. That's a 220% savings in image sizes. You're literally saving your users money because they don't have to download 600 kilobytes of data anymore. Step 2 is to consider the image format. So here, if we use JPEG, it's a 500 kilobytes. But if we use WebP, then it becomes 340 kilobytes. And maybe I need to support Internet Explorer, so I send the 8 kilobytes for the picture fill, polyfill. And now we're at 348 kilobytes. So now we're at a 316% savings in image sizes. And that's just the initial homepage load. So then step 3 is to choose the best image quality, especially on those smaller images, those icons. Again, we don't need even 80%. We could just save them at 20%, and they're going to be fine. They're a small icon that nobody's going to see much of the difference there. If you really want to send large images, then please consider using Picture again. So Picture allows you to use multiple sources with source set that lets you also enter the media query size that you're sending. So if your users are on small mobile devices, which is now the standard, don't send them these massive Retina images. You can use this. It's super useful. Picture is a really favorable solution for all sorts of image optimizations for your users. And step 4 is to cache these images. So you can do this by editing your htaccess. This is more of a server-side thing. I didn't dig too deep into server-side optimizations in this presentation, but some of these things you can also do on the server side. But a month ago, I was speaking at a conference in South Africa, and I had some really interesting insights about the web from the people there, from the people living in South Africa who attend the conference. When the people in South Africa visit international websites, they said that it's just a really painful experience, especially with moving images and parallax and all of those things on the websites. Some of them even call these websites unusable. And one woman I talked to said that if it doesn't work offline, it just won't catch on. And then I looked into this more. I love this quote. I love this idea. Of course, this makes sense. YouTube has also caught on to this. I dug deeper and I found that YouTube, it's now available if you have YouTube Red offline everywhere, but initially it was only available offline in these 12 countries, and it still is available offline in these 12 countries. South Africa is on this list, and so is India, that country that has almost double the internet users of the US. So if YouTube is recognizing this, we need to be recognizing this too. Performance optimization is really important for these large markets. And then step 5 is to literally profit. Amazon calculated that a web page slowdown of just 1 second cost it $1.6 billion in sales each year. So even if you don't really care about page speed and information access, improving performance is still worth it in the end. Just to leave you with a few image optimization tips, probably don't send an image larger than it needs to be. Be aware of the emerging image formats, their pros and cons. Picture element is your friend. It's really great to use. Compress your images, especially smaller images, to low qualities. Always run your images through an optimizer. Image optim always and often. Cache your images. Small improvements are still improvements. and educate your entire team. So take this information, take it to your team, and teach them. This is a team effort. It's not a design problem, it's not a development problem, it's a team problem. It's really about finding balance. I know this is super heavy-handed on the optimizations, which are really important, but it is about finding the optimal solution for your team, which is probably a mix of automatic solutions, semi-automatic, and then manual solutions for image optimization. This is one of my favorite Bob Ross quotes because he's just so brilliant. But this is how I think that the web should be. Like, people shouldn't be obstructed by media to use the web and to get information from it. The web should be free, a place for users to ebb and flow wherever they want to, access the data they want to, without worrying about how much it costs them. So build happy little pixels to make happy little websites and happy users. It just boils down to this. There's one concept: build a better web. Build a web that doesn't make information a privilege. Build a web that's faster and more accessible, and consider that small incremental changes can have a large impact overall. Build something that people don't love, but more importantly, build something that people don't hate. Thank you.